A possible link between space weather and earthquakes.
Researchers at Kyoto University in Japan have proposed an intriguing idea: space weather, especially the intense bursts of solar energy known as solar flares, can, in very specific situations, help trigger large earthquakes.
This recently published theoretical study does not aim to predict earthquakes, but rather to explain a physical mechanism that connects what happens in the Earth's upper atmosphere with what occurs in the Earth's crust. It all begins with strong solar activity. When the sun releases a large amount of energy in a solar flare, it rapidly alters the ionosphere, the layer of the upper atmosphere filled with charged particles, such as electrons. This causes a measurable increase in the total number of electrons, something that scientists monitor with navigation satellites like GPS. The authors suggest that this change in the ionosphere creates a kind of electrical link with the Earth's crust. In regions where the rock is highly fractured and contains water under high pressure and temperature, near supercritical, these areas act as small natural capacitor structures that store electrical charge. When the ionosphere becomes more negatively charged at lower altitudes due to solar flares, this excess charge generates electric fields that propagate downwards, reaching tiny voids and fissures in the rock on an nanometer scale.
Within these voids, the electric fields produce considerable electrostatic pressure estimated at several megapascals during intense solar events that significantly increase the number of electrons in the ionosphere. This extra pressure can influence how fissures propagate and join, acting as a small additional push on geological faults that are already on the verge of rupture. Scientists compare this force to other subtle influences, such as tides or gravitational force, which also affect fault stability. Although to a much lesser extent, the study mentions interesting coincidences, such as the intense solar activity that occurred shortly before the earthquake on the Noto Peninsula in Japan in 2024. Furthermore, before some major earthquakes, scientists have observed changes in the ionosphere, such as increased electron density, lowering of the ionospheric layer, and alterations in the propagation of disturbances. Traditionally, these changes were seen only as consequences of the accumulation of stress in the Earth's crust before the tremor. Now, the researchers propose that there may be a two-way relationship. What happens in the crust affects the ionosphere, but disturbances in the ionosphere can also, on rare occasions, influence the crust.
It is important to emphasize that this does not mean that the sun directly causes earthquakes, nor that every solar eruption generates a tremor. The authors make it clear that the effect would only be relevant under very specific conditions, when the fault is already critically loaded and close to rupture. This is not a seismic prediction tool, and temporal coincidences do not prove cause and effect. The work consists of a theoretical hypothesis that integrates plasma physics, atmospheric sciences, and geophysics, and scientists hope that future research, combining detailed ionospheric data with space monitoring, will help test and refine this idea. This proposal opens a new perspective on how our planet interacts with the space environment, showing that seemingly separate systems, the upper atmosphere and the deep crust, may be more connected than we imagined.